Okay, we're entering a new graph, and I hope you like this one. The parent function is the graph of 1 over x. And you end up having this kind of plus sign of asymptotes, these bizarre lines that the graph approaches but never crosses. And you have a curve in the upper right and a curve in the lower left area. It's kind of a quirky shape, but this is a parent function that we should know. That's the basic shape. But there's a lot of vocabulary that goes along with this. This line is going to be called a horizontal asymptote. It's normally the line y equals 0. If you remember Hoy-Vux, a horizontal line is y equals. This is a vertical asymptote. It's a vertical line that guides behavior, and it's the line x equals 0. Hoy-Vux, vertical lines are x equals. So there are different parts that we need to know. I just thought you might want to see some graphs. Those asymptotes can move to different places, and the graphs sometimes cross axes, sometimes they don't. So we're going to look at a bunch of things. We're going to look at x-intercepts, we're going to look at y-intercepts, we're going to look at vertical asymptotes and horizontal asymptotes. So first, vertical asymptotes. You want to see what is bad, because we can never have 0 on the bottom of a fraction. So if I had a function that was this, x can't be 0, that would be where the vertical asymptote is. This bad x would be a -2. So as I'm graphing, -2 would be the location of the vertical asymptote. Same thing here. Even though it's busier on top, you only look at the bottom. So the vertical asymptote, the bad x, would be going again through that -2. Here I'm just focused on the bottom, so this bad x would be a 5, meaning the vertical asymptote would be over here at 5. And the last one, even if you have something wacky with a fraction, you're going to use that +3/2 just to the right of the origin between 1 and 2, and that's your vertical asymptote. So for a vertical asymptote, it's going to be a line of the form x equals. Next part of the graph we need to know about is when it crosses the y-axis. And if you think about what you know, you've been doing straight lines for a long time. That's the y-intercept. I know about parabola. If a parabola crossed, that's the y-intercept. So I know I have a y-intercept when the x value is 0. So how do you find the y-intercept? You set x equal to 0, and you do a little math and see what you get there. Next part of the graph is a little bit crazy with fractions. We're trying to figure out what x makes the top 0, because if I can make the fraction equal to 0, that's when y is 0. So I'm looking for x-intercepts, right? And x-intercept is some number comma 0. If I look at this first one, how do I make that fraction equal to 0? If x is 0. How do I make this fraction equal to 0? If x is -4, right? Because -4 plus 4 over 7 is 0 over 7, which is 0. Focus on the top. Even if there's something busy down here, x would be -4 here. And can I make this fraction equal to 0? No. And so this, if this was your graph that you were given, if you were saying, hey, let's graph 8 over x, it's not going to have an x-intercept. So just something to think about. If you want to make a fraction equal to 0, focus on the top. If there's just a number, you're not going to have one. And the last part is really kind of bizarre. You need to remind yourself what degree is. The degree goes to the highest exponent. So this is a second degree polynomial. This and this are first degree. This is a 0 degree polynomial. And when you look at these rationals below, we're looking to see if the top or the bottom has a higher degree. If the bottom has a higher degree, you'll see that in these two examples. The most common horizontal asymptote is y equals 0. That's an automatic. If the bottom has a bigger degree, you're automatically going to have the x-axis as your horizontal asymptote. If you have the same degree, you do something kind of quirky. Think of what the coefficient is. You make a fraction out of that. And so here, your horizontal asymptote would be y equals 3. That's if they have the same degree. And then the odd case is this. If it's a bigger degree on the top, because of that squared over a single term, you do not have a horizontal asymptote. So those are the different parts of a graph. Happy graphing.